Hello, everyone. I'm here to present today on the Winnipeg-Wide Amateur Radio IP Network, or VA4WAN project. Thanks for having me back this year. I'll try not to say all the time, and I'll try to make it entertaining. So, a quick primer on the reason for the existence of this network. What is amateur radio? What and why? The International Telecommunication Union and most national governments allow access to certain frequencies in the radio spectrum for amateur radio use. This is only for non-commercial experimentation and community use. The users are licensed per country and with a related call sign. For example, here in Manitoba, the call signs all begin with VE4 and VA4. And the restrictions on use are pretty specific. There's no encryption except for certain cases, no offensive content, no music. So it's not broadcasting, it's for communication and testing pretty much. Reasons for the existence of amateur radio are to push forward the innovation and research in radio communications, for people's personal development and accomplishment, for community service, and also for emergency or disaster preparedness. The amateur radio frequency rights or allowances are quite spaced and wide in the spectrum. Between, let's say, the average spectrum use in the by humans in the range of about 1 megahertz to 6 gigahertz. Below that range, antennas become very big. Above that range, signals are very line of sight. They won't go through any notable obstacles. So most of the human usage is in that range. The amateur radio have something around 100 different little slices of spectrum that they can use. Amateur radio operators are secondary users, so that means that companies or individuals who are licensed, who pay for frequencies, have first dibs on frequencies. And if ever there's interference between licensed users and amateur radio users, the amateur radio users need to stop the use or change frequencies. In all these slices of spectrum that amateur radio operators have allowances to use, many of them have quite a small channel size. For example, 0.02 megahertz wide in one of the most popular bands. For our project, which is high-speed data, most of the equipment is efficient of about 3 to 5 bits per hertz. So that means if you want to get a speed of equivalent 3 to 5 megabits over the air, you need spectrum frequencies that about 1 megahertz wide. In the frequency allocations, that limits a lot of lower frequencies are not that wide or don't have channels that wide. So that means the frequencies that we are allowed to use are mostly 900 megahertz and higher. For example, 2.3, 3.4, or 5.9 gigahertz. Now, who uses amateur radio? This is an accurate representation of an amateur radio operator, at least in the 80s. Yeah, well, again, in the 80s. That's why. He'd be relative age today. But cool guys like that. In Manitoba, there's currently about 1,800 amateur radio operators or hams that are licensed. Most of them, their usage of the ham radio hobby is personal multi-user voice communication. So that means chatting on mobile walkie-talkies, or they have stations at home that are the same thing, voice, multi-user voice. Most of these are either older analog systems or newer digital modes such as D-Star, which are lower speed digital, like the total network speed is measured in kilobits or barely 1 megabit. Range and distance is one of the primary attempts at pushing the envelope. So a lot of hams, they speak across Manitoba or with the right antennas and on the correct frequencies. They can speak across Canada, sometimes across North America. In some cases, sunspots or other effects, natural effects, can even mean that they can bounce off the troposphere and speak to someone on the other side of the planet. So distance attempts can result in pretty impressive distances. A number of hams in Manitoba are involved in community projects, for example, Manitoba Marathon Communication Support and other such community service. There is experimentation. I know one of the hams in Manitoba, VA4WAN, has designed his own hardware to bounce signals off the moon, which is some very impressive feats of engineering. And our project, VA4WAN, is more of this experimentation. There's disaster preparedness. And amateur radio is often one of the best platforms for inexpensive, very long distance communications. It's open systems, they're easily accessible or repairable, and because the users are the technicians, it's often quickly deployed or repaired. In the cases like we've seen recently in Puerto Rico, most of the island's communications were destroyed, but amateur radios can still get through using their long-distance communication or local communications. And here in Manitoba, during the floods, amateur radio has really helped support efforts for that. Now, there are still some concerns with amateur radio. Most of the communication protocols, they range from about 100 years old to 20 years old. So that's analog voice to digital voice. Amateurs spent lots of time experimenting for distance records, but there's not a lot of experimentation for systems designs, protocols, apps, etc. So there's while there's pushing the envelope, it's in certain directions that are mostly distance-based and not, and there's some aspects that are not explored as much. There's packet radio, which can be which a digital radio system can be IP-based, but actual speeds are like 9600 baud. That's not a typo. That's the actual speed it runs at often. There are new digital systems such as D-Star, DMR Fusion, but these tend to be proprietary, still lower speed. You are paying maybe $400 for a basic voice walkie-talkie, which in the day of smartphones seems kind of ridiculous. And they're pretty limited in comparison to IP networks. Some people have been saying that amateur radio is stagnating or dying, almost like the BSD operating systems. But there's a huge amount of technical innovation in modern days, but much of it doesn't involve the amateur radio hobby. There's a lack of integration with internet platforms. And at the bi-yearly amateur radio flea markets, the average age is 60. So there's some concerns there. For example, here in Manitoba, there's the Manitoba Repeater Society. This is a nonprofit that operates a network of 9 voice repeater towers across Manitoba. It has very wide coverage from Falcon Lake to Bruxelles, from Morris to Gimli. It is very, very, very useful for amateur radio purposes and in the community, but the project has very limited finances, and some equipment is about 30 years old, and I think some equipment still runs on vacuum tubes. Again, don't get me wrong, it's a great network, but it has a few issues. Some of them, a lot of the issues are due to budget, but also some of it is due to old ideas and design. It's an analog network, so if there's noise at one end, it travels across the whole network. There's no redundancy or upgradability. It's mostly single protocol for voice. It's single user access, so if one person is using it as one end, it kind of uses the whole network. There's no monitoring, alerting, or statistics, and it's very limited integration to other systems. So it served Manitoba for about 30 years very well, but this is if this is the biggest network in the community, we need something a bit newer and more modern is kind of the thought behind it. Amateur radio does have, so this modernization looks at bringing IP or Ethernet to the amateur radio. Of note, in the early internet days, amateur radio operators, they reserved a big slice of IPv4 addresses for ham radio. So that's the 44 dot network. It's a /8, so 16 million IP addresses for hams. And I can tell, Oh, that's weird. For 16 million IP addresses for hams, that's a lot, and very, very small percentage of that is actually being used today. So a recent approach is to bring the design of IP or Ethernet networks to amateur radio. So that is a digital system that allows multiple concurrent protocols and uses, redundancy, upgradability, those are easily supported, multi-user traffic in all directions, easy monitoring, alerting, and statistics based on industry standard protocols such as OSPF, BGP, using VLANs, etc., and integration to the internet and other systems. Unlicensed frequency wireless systems are commercial off-the-shelf, and these have some overlap of amateur radio bands. For example, 900 and 2.4 and 5 gigahertz systems, also some 3 gigahertz systems, some of which are 5 gigahertz Wi-Fi chips on frequency converters to 3 gigahertz. That brings us to the amateur radio Wi-Fi network concept. The idea is to modify outdoor equipment from 2.4 or 5.2 to 5.8 gigahertz unlicensed bands used for Wi-Fi into the 2.3 or 5.9 gigahertz bands that is allowed to amateur radio. Also occasionally from 3 gigahertz to 3.4 gigahertz. There's many names for such networks. HSMM, Amateur Radio Data Network, Amateur Radio Emergency Data Network. That is about 100 site project in America, but it's mostly unlinked individual sites. One of the leading projects is the VA4WAN near Seattle. It has developed best practices and standards that other networks are applying, although our VA4WAN project is not fully compatible to those standards at present. It operates the Puget Sound data ring, quite advanced network around Seattle. And interestingly enough, one of their main techs is from Winnipeg. About 10 years ago, when there was the Wi-Fi Winnipeg days, me and him operated a radio site on Demerol at a machine shop. That brings us to the VA4WAN project. This was begun in 2014 by a group of amateur radio operators. So that's me, Dan Kaiser, Derek Hay, William Franzen, are the main guys. There's also many other hams that have donated time, money, resources. Our goal is to implement a free and open HSMM network in Winnipeg. We started at 55N, one of the tallest buildings in Winnipeg. Now we have 5 sites. We're hoping to build to about 12. 55N in Osborne, STV in St. Vital, TRA in Transcona, Inc. in Inkster, WDL in Woodlands, and we're working on one in St. James. So this is using Ubiquiti or MikroTik outdoor Wi-Fi equipment. The goals are to allow experimentation, community service projects, emergency preparedness, and other ham uses. The team is, we are not an ISP, only hams are allowed to use it. It's not for business, music, or non-ham made movies. There's a joke about ham porn there, I won't get into it. So one of the main challenges of this is we're like a wireless ISP. We're operating a fixed wireless Ethernet or IP network, except we don't get paid to do it. So that adds additional difficulties. We see the general risks or common mistakes by new wireless ISPs. Or we know of these risks and try to avoid these general risks or common mistakes. That is incorrect hardware, like radios that can't survive minus 40 Celsius, weak mounts using indoor Ethernet cable or zip ties outside and they fail in the sun, not following industry standards for wind load, mounting, cabling, attachment, grounding or lightning protection, not understanding manufacturer exaggerations or lies, and not designing networks to be sustainable, upgradable, not developing our own quality standards or requirements, and not planning or documenting or monitoring enough. The solution to that is experience and industry connections. I've been in the wireless industry, wireless ISP industry about 10 years. I've installed personally 1,000 sites. I've been in AFMUG and other groups. So I've seen a lot of experiences, mostly good, some bad, mostly not our company. And I have an idea of what to do, what not to do. The main guys in our project have been hams for years and know concepts such as mounting, wind load, lightning protection. Equipment. So wireless internet equipment is anywhere from $100 to $10,000 per radio antenna set. It depends on many factors: manufacturer, speed, requirements, bandwidth, distance. Most sites will have a minimum 3 radios, so you can picture the cost from there. That's usually two radios for directional point-to-point backhaul links to other sites, and 1 radio for user access, such as an omnidirectional antenna. We also need mounting, routers, UPSs, cabling, etc. So the solution to all that equipment is lots of deal hunting and donations. From many wireless internet service providers and some organizations, we get older generation radios or antennas donated. From businesses, we get routers, switches, UPSs. We've repaired equipment. We've gotten many MikroTik routers from the late 2000s that had bad capacitors, and these days I can recap one in 5 minutes. We do deal hunting on eBay, Kijiji extensively, and our members have gone to great efforts to get, and friends have gone to great efforts to get gear, including dumpster diving. And William can nerd charm gear out of anyone. So frequency conversion. So converting 2.4 or 5.2 to 5.8 gigahertz Wi-Fi equipment to the 2.3 or 5.9 gigahertz amateur radio bands. Some Wi-Fi chipsets won't work outside the unlicensed brands, such as Broadcom's, but those chipsets suck anyways. The most popular chipsets come from Qualcomm Atheros, and those are great. If they're unlocked, most can cover from 2.3 to 2.7 and 4.9 to 5.9 gigahertz, so quite nice range. Many older radios from Ubiquiti and MikroTik were unlocked, or they supported the compliance test mode, which did that. But then, questionable operators ran them at 5.6 gigahertz and blocked airplane radar, so planes couldn't land. And the US FAA was really not happy, and they called in the FCC. And there were other such stories. Because of that, now all new radios sold in America and some in Canada are locked to unlicensed bands, and out-of-band usage is not allowed. Solution is to use older radios, or there are some out-of-band hacks on new radios. Some methods are publicly known online, although newer firmware often removes that, which is a problem. And William and I have been developing some non-public radio hacks that we've had some success with. I'm definitely over time already. So, challenge. Tower space can be expensive. Average worth is anywhere from $50 a month for a green leg in the middle of nowhere to $1,000 a month to the tallest professional building in downtown Winnipeg. Our project's budget is a stable $0 a month. So, solution, donated tower space. Many organizations, they understand amateur radio's community service, nonprofit, educational aspect. There are some wireless ISPs or two-way radio providers that have nice towers. Many of those companies have entrepreneurial origins, so they are impressed by our build it drive. There are some large organizations. There are private owners, often more rural areas, and there are other hams who already have co-location agreements on sites. So those have gotten us tower space. Tower work is very expensive. If you hire professional tower climbers, they charge over $1,000 a day. That's our 2 or 3 person trained certified crew, climbing harnesses, big truck and trailer, gas, full set of tools, lots of mounting hardware and spare parts, insurance, office work, and documentation. Our budget is about $40 a day to buy people food. So quite a difference there. The solution is dedicated hams. I'm a certified climber, and we have a few other hams who are as well. As a group, we've got personally owned tools and extensive hardware in stock from other ham projects. It's careful planning so that we don't need a huge trailer. We have personal vehicles, gas, climbing harnesses, and the rack insurance for amateur radio tower sites covers our project at a quite reasonable price. Wi-Fi protocol. Issue, Wi-Fi protocol is junk for long distance usage. There's the hidden node problem. It's susceptible to packet loss. It degrades heavily with distance interference. It's contention-based, which means transmit randomly and you hope for the best. So a 300 megabit Wi-Fi access point will achieve about 150 megabit in ideal conditions. Difficult conditions, say 50 clients and interference, you'll get maybe 5 or 20 megabit real speed. Much better protocols exist, but those don't work for a project due to cost, or they don't run at ham frequencies. So there's TDMA modified Wi-Fi hardware where companies reprogram Wi-Fi chips to operate on better time scheduled protocols. Lots of these are available, and they're all proprietary and incompatible, which RMS tells you is a bad thing. Spectrum. So Innovation, Science and Economic Development Canada, ISED, formerly Industry Canada, specified spectrum access rules. Legally, it's paying users, then hams, then non-licensed users. In practical use, we don't want to suffer the huge amounts of interference in unlicensed bands in populated areas, and we don't want to interfere with or annoy the WISPs who give us free equipment. So practically, it's paying users, then unlicensed users, then hams in order of priority. From the above, some parts of the 2.3 and 5.9 gigahertz bands are not fully usable. So the solution is we occasionally search the ISED SMS database or the TFL files to find out if there are new users of 2.3 or 5.9 gigahertz or other licensed spectrum that we want to use, and we check that our usage does not interfere with them. Access control. So we have a fully open, unsecured, citywide network directly connected to the internet, and it's not a great idea for multiple reasons. We want some control of that without violating ISED regulations, laws, or amateur radio spirit. So the solution we've had is careful design. The user access network in terms of Wi-Fi protocol is open and unencrypted, but it's a walled garden design. Users get private IP addresses that only have local network access, not internet, until they contact us with their ham licensed information. And the backhaul or intrasite point-to-point links are securely encrypted with WPA2. ISED is pretty much okay with that as long as all security keys are always available to them. And system administration is not done over unsecured links. Challenge, community involvement. This approach is new to Manitoba. It's rare in the amateur radio hobby. Wi-Fi in Winnipeg 10 years ago laid some groundwork, and many of our members started there. The Manitoba amateur radio groups have a long and often unwritten history, and a lot of hams are older and set in their ways. Also, we needed tower space and space to store test equipment. So the solution was community involvement. Some members, especially Dan and Derek, have been extensively involved in the Manitoba amateur radio groups, WORK, RAC, WSC. As a group, we've done presentations for and are getting involved with other projects. We supply internet access to repeater sites, the WSC Seniors Radio Center, and ham events. And WSC permits us to use their club building on St. Mary's for equipment storage, staging or testing, and meeting. So progress of our project. We started around 2014 with one site. Now we have about 5 sites. Progress was slow, but now we're getting a lot faster and more efficient. All sites have routers. Most have UPSs and redundant backhauls. The network was temporarily bridged between all tower sites, and now we're finally converting to OSPF for redundancy, load balancing, and simply good design. 55N is the central site and our current internet feed. We have a 100 megabit connection by having a local fiber to LessNet's cabinet. We have 2.3 and 3.4 gigahertz sector antennas covering a lot of Winnipeg, and 5.9 gigahertz point-to-point backhauls that link to our other sites. We have multiple IP ranges routed to the internet via our provider's BGP. So that's 44.135.116 to 44.135.121. Here's a tour of some of our tower sites. We will visit 55N, a tall building in Osborne, where we have equipment on the north side, a dish on the west side, and a pipe on the south side. There's TRA, a 140-foot tower in Transcona, where we have the backhauls to other sites at around 50 feet, and the user multi-point access points around 110 feet. And Inc., an 11-story building in Inkster, where we have two of the non-penetrating sled mounts. The lower one is for point-to-point backhauls, and the higher one is for multi-point access points. So, top of 55N, at the very top we have 5.9 gigahertz Omni for testing. Below that we have three 90-degree sectors, west, north, and east, for our 2.3 gigahertz users. Behind that there's a 5.9 gigahertz panel, which is a point-to-point to the U of M. Below that, we have that Big Dish is another companies. We have a public webcam pointed to downtown, and we have a 5.9 gigahertz point-to-point flat panel that later was repointed to the Inkster site. That's a north tower. On the west side, we just have a Big Dish going to Woodlands. Later, we've replaced that with a 2-foot panel. On the southwest, we have a mast with 4 antennas. At the top, there's a 90-degree sector with 3.4 gigahertz. Below that, there's a 90-degree sector with 2.3 gigahertz. So our users can use either, depending on what they want to test. A 2-foot 5.9 gigahertz panel, that's a point-to-point to St. Vital site. And a 2-foot 5.9 gigahertz flat panel, that is a point-to-point to the WSC Senior Center. We have a rack there with the UPS and wire mesh, PoEs and routers, and our servers, back of the rack. TRAS site, this is our tower. We've got 2 flat panels to other sites, St. Vital and Inkster, and a 270-degree sector, and an omnidirectional antenna. Both of these last two are to feed users. Inkster site, we have non-penetrating roof mount on the roof with 2 flat panels to link to other sites and 2 dishes that go back to 55N. And at the top of the parapet, the other building, we have a 2.3 gigahertz omnidirectional antenna for user access. We need to put more weights on there. And this is a simple rack with router and PoEs. Our plans, we're trying to get new sites in certain locations. We are negotiating the following: West Winnipeg, Selkirk, Petersfield, Steinbach. But we're also looking for possible sites around Northeast Winnipeg, Portage la Prairie, and Brandon, and a path going to there from our current network. For the network itself, we want to finish network updates, set up a second main site other than 55N with an internet feed, get more users on the network, get more apps, platforms, and projects, and also get more ham community involvement. In conclusion, this is a big and ambitious project, but it's bringing amateur radio into the future. It may become one of the bigger such systems in the world. Our core team has spent hundreds of hours and a large amount of resources and money on this hobby. But the ham and business community provides a huge amount of support to make our project successful as well. If you want to get involved, for non-hams, we'll answer questions. So you may want to consider taking the course and test to become a ham operator, which is around under $100 and 30 hours of class and study time. For hams, we'll help you connect, and we're looking for help for tower climbers or other resources, or just people who are interested. Thank you very much to our very dedicated supporters who did so much. That is Les.net, High Speed Crow, Prairie Sky, Prairie Mobile, and many others, and all the following individuals listed here. If you want to contact me, there's my contact info. VA4WAN, there's our main website, and the Facebook group, and Dan's blog, which has updates. I think Dan is in back there too, in the corner. And there's also my BSides Winnipeg 2015 Basics of Radio Waves and SDR session on YouTube if you want more general radio information. It's annoying to listen to, but it's pretty good. And there are amateur radio community events, including bi-yearly flea market, monthly presentations, and yearly field day. These are open to everyone. So thank you very much for your time, and let me know of any questions.